This project is a product of the School for Field Studies Australia Campus Fire Ecology Lab.
I'm Amy Gaulke.
I'm Audrey Crawford.
I'm Daniel Kim.
I'm Owen Tsunoda.
And we are the Flame Ecology Lab.
We acknowledge the traditional owners of the land that we are researching on. We pay respect to elders, past, present, and emerging.
Wildfires have ravaged Australian lands in recent years, leading to the burning of nearly 42 million acres and the deaths of 3 billion animals. As Australia is home to many endemic species, this is a devastating blow for biodiversity. It's also a great loss for natural resources, as fires have resulted in the loss of countless habitats, as well as affecting agricultural crops and livestock. We wanted to do research to aid in the fight against wildfires.
We had one main question that we wanted to answer with our research, and that's how the burning capacities of 3 different biomes in northeast Queensland compare: savanna, seasonally dry tropical forest, and rainforest.
We looked at 3 different biomes, and we thought that it was important to study the flammability of local species. One of the biomes we looked at was the rainforest, which can be classified by its high levels of rainfall and biodiversity, as well as its multi-layered canopy. For this, we used data from the Atherton Tablelands. We also sampled trees from the dry forest of Chillagoe National Park, which can be classified by its longer dry seasons, enclosed canopy, and lack of ground-level vegetation. Finally, we looked at the savanna of Mount Baldy, which can be classified by its ground-level vegetation, such as grasses, and lack of a closed canopy. We expected to see the rainforest have the lowest levels of flammability, while we expected the savanna to have the highest levels of flammability.
We will now give a demonstration of how we tested our predictions.
We start by putting the sample on the grill to simulate an oncoming wildfire. Then, we use the blowtorch to ignite the flame.
We use a temperature gun to measure the maximum temperature of the flame. We use a stopwatch to measure the burn time, and a meter stick to measure the maximum flame height.
Unlike what we expected, we found that rainforest and savanna biomes were the most similar, and the rainforest biome was found to be the most flammable.
In this graph, each of the points represents an individual species. The rainforest and savanna are the blue and green dots, respectively, and you can see that they have a lot of overlap. This means that they are very similar in terms of flammability.
But what does this all mean, and why is this important? This is important because as droughts are expected to increase in frequency and severity in the coming decades, it's essential to know which biomes are the most at risk for fires.
Our results helped us identify rainforests and savannas as flammable at-risk biomes, as they burn relatively well when they are dried.
Now, a question we want to know was why that may be.
After doing research, we found that this may be due to the lack of adaptations that rainforests have to wildfires due to their typical moisture levels. A lack of moisture in rainforests due to drought could, therefore, be detrimental and increase fire likelihood.
One of the goals of our research is to find a method of wildfire management that's applicable in both urban and natural spaces. After doing some research, we ended up deciding on a method known as green fire breaks, or green fire walls. So what is a green fire break?
A green fire break is a section of lower flammability vegetation that's planted surrounding an area of higher flammability vegetation. Its purpose is to serve as a break or stop in a wildfire.
This is also why our data tried to identify native species that were the least flammable in each of the biomes. The rose silky oak was found to be the least flammable in our rainforest biome. Additionally, in the savanna, native pigeon peas were found to be the least flammable.
These species could be suitable for a fire management strategy known as green fire breaks.
We believe that our data can help improve land management practices in each of the different biomes that we studied.
Especially in private properties where resources might be less available, highly effective, efficient practices like green fire breaks should be utilized.
Utilizing land management practices based off of these results can help with the reduction of fire risks, especially as climate change continues to threaten to raise temperatures and fire likelihood.